Okay, this lesson is going to tackle how to do a two-way ANOVA in StatCrunch. It'll also be very similar to do it in Excel, and it basically all comes down to proper formatting of the data in a spreadsheet. Okay, so faced with a question like this, if you click on the data table symbol, it'll bring up your data. Okay, so here's your typical two-way ANOVA data. You've got data that are classified two ways. Vertically, they're classified by the subject's self-esteem. So these two columns represent a subject with low self-esteem, right, medium and high self-esteem. And then it's also broken down horizontally by columns as the target self-esteem is low or high. So in this scenario, they had subjects that somehow were ranked low, medium, and high self-esteem. They probably took some sort of Likert test. And then they described people in writing and had the subjects determine whether or not those people had low or high self-esteem. So these are representing whether or not they scored the target as low and high. So that's how the data works. In order to calculate it, we need to get the data into a spreadsheet in the proper formatting, and unfortunately the computer system does not do it for us well. If you go to these two little blue boxes here and click on it, it brings up your options for opening it in StatCrunch, copying it to a clipboard, etc., etc., etc. If you think like we've done previously, we can just open it in StatCrunch and everything will work well. This is one example where it doesn't, because it doesn't format the data properly. It puts it into multiple columns, which is not going to work for us when we go to try and calculate things in StatCrunch, because if we go to Stat ANOVA two-way, because this is a two-way ANOVA, it asks for the responses are in what column, the row factor is in what column, and the column factor is in which column. Well, how does that work, right? Our column factor, as we saw from the previous window, was the self-esteem level of the individuals. Well, that's these three columns, so we can't have it in three different columns. And then the row factor, right? The row factor was whether or not they ranked the described person as having low self-esteem or high self-esteem, and that's here and here, but you've got all these blanks, right? And then responses, well, the responses are all over the place. So this is not formatted correctly at all. It's not going to work. So I'm just going to close that. So instead, let's copy the table to the clipboard and then put it in Excel. Again, it's not going to be right in Excel, but it's going to be easier to move stuff around and copy and paste and do what we got to do in Excel, and then we can copy from Excel into StatCrunch. Okay, so basically what we need is we need all of our responses, i.e. our data, in one column, and right now they're not. They're in three columns, right? So here's where it gets tricky. This is what we're going to be striving for ultimately, right? We're going to have a response column, we're going to have a row factor column, and a column factor column. So in here is going to be all of our data, right? Blah, blah, blah. And then next to it, it's going to be the row factor. So in our case, it was low self-esteem and high self-esteem. So we can say low, 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 and then maybe these two were high. And then the column is going to be the self-esteem of the individual. So let's say the first one was low, the next one was medium, the next one was high, this one was low, this one was medium. Okay, so just so you understand what's going on, that means that this 2 was the response number that came when a subject with low self-esteem categorized the described subject as having low self-esteem. This 5 was the score that came from a subject who had medium self-esteem but said the described subject was low. This 4 came from a subject who was scored at having high self-esteem and then designated the thing that they read, right, was low self-esteem. Okay, here's someone who had low self-esteem, thought that the description was of someone with high self-esteem. Here's someone who had medium self-esteem and thought the description was someone with high self-esteem. So you see how the descriptions work that way, and all we need to do is make all this data fit into that formatting of responses, row, and column. Okay, so we just need to keep track of what everything is. So these numbers here are a subject who had low self-esteem, right, and then ranked the target as also having high self-esteem. Okay, so let me delete this out of here, and we will Control-C and paste our numbers there. So these numbers all had a row description, right? A row factor. Remember, the row is how they rank the targets. So these rank the targets as low. And then I'm just going to drag this to copy all of those as low. Then they also had a column factor of low as well. So I'm just going to drag it over here, which copies over there. Okay, so those numbers were low and low. All right, let's copy these numbers here. Control-C, Control-V. Those still had a row, right? A row factor of low. But they now had a column factor of medium. And I'll go back up and show you, right? Because these came from the ones who had a medium. All right, and then I'll do the last one. Here. Row factor for these, still low. Right? But now, copy and paste those, and those are the high ones. Okay, and then we just now add on these. Kind of repeat the process. So, copy, paste. Now, what's the row factor for these? High. Right, because those numbers came from here, and those are the numbers that represent scores for the people who said the target had high self-esteem, but they themselves had low self-esteem. So that's the column. The column is low. You can do this as well because Excel is smart enough to follow a pattern. Okay, 2 more to go. These. Those. These are all still the high columns, but now the high rows, now medium columns. And then the last one, these right here, those are high and high, right? High row and high column. Okay, so now these 3 columns have our data in the proper formatting so that we can run Two-Way ANOVA. So I'm just going to copy those, go back to this thing here, and we can just launch StatCrunch by pushing that button. I'm going to go ahead and maximize it so we can see what the heck we're doing. And then it's just a matter of Pasting. All right. Now we're going to have a problem here with these 3 words being here. So we don't want to do that. So let's undo paste, and let's not copy those, right? Because those are our headers. That's going to give us a problem. So let's just select our data. Paste it there. There we go. That should be easier. Now, if we go to Stat Two-Way ANOVA, well, our responses are variable 1. Right. The row factor, remember where the row factor was? Hopefully you do. That was variable 2. And the column factor was variable 3. Let's calculate, see what we get. And there it is. Now, because we didn't title these things, right? We didn't title our columns. It just says var 2, var 3, and interaction. But we always look at our interaction first. There's our p-value, right? Variable 3, remember that's our column factor, and variable 2, that's our row factor. So let's go back here and see what the question was. State the null hypothesis and the alternative hypothesis. Well, the null is that there is no interaction. The alternative is that there is an interaction. Now, what is the value of the test statistic? So which of these 3 is our test statistic? Well, here they're asking for the interaction. So what's going to be our interaction 1? This one, or this one? Alright, round 4. 6, 2, 0, 7. Yay, we're getting it right. Corresponding p-value 0.0001. State our conclusion. Do we reject, excuse me, or fail to reject? Well, the null is that there is none. We got a really small, right? So when the p is low, the null must go. So we reject. There is sufficient evidence to warrant rejection of the claim that measures of self-esteem are not affected by interaction, but because we did see that we have an interaction. Right? There does appear to be an effect from interaction between blah, 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 blah. Check answer. Okay, and since we do have an interaction effect, we're pretty much done. We can't test for a row effect. Excuse me, and we can't test for a column effect. But if we were to test for those, if we were to ignore this interaction, if this came back with a really large p-value and we didn't have an interaction, then we'd have to remember that variable 2 was our row effect. So this would be our f statistic, this would be our f statistic, this would be our p-value. So we would see a row effect, for sure, right? Really small p. This would be our column variable. This would be the f statistic for the column and the p-value for the column. So we would see an effect from both row and column had there not been this interaction effect. But I think the biggest problem with these questions is getting the data into the proper formatting, and that's the big thing here. So you just have to copy and paste it so you get all the data in one column, and then each data value is described 2 ways, right? What was its row factor and what was its column factor. So these data values here, right, all corresponded to something that had the low target and low subject. So that's why they're low, low, right? And then these ones were low, medium, because, again, they were from this spot right here, which had low row effect, right, row going in this direction, and then medium column effect, right? So they were low, medium, etc., etc., etc. So that's what you got to do for your data. That's the big sticking point with these. Hope that helps.